For decades, chronic hepatitis B has been this quiet but totally relentless global health crisis. It's been a long, drawn-out war for so many people. But, and this is the exciting part, we might be right on the edge of a breakthrough that could finally turn the tide. So, let's get into it.
Just take a look at this number, 300 million. That's almost the population of the United States. That's how many people right now are living with chronic hepatitis B across the globe. It's often called a silent epidemic because it quietly leads to some really serious stuff: liver disease, cirrhosis, and even cancer.
So for these millions of people, treatment has been a lifelong thing, a constant daily battle just to keep the virus in check. But what if I told you a whole new strategy is coming? One that doesn't just, fight the symptoms, but actually silences the virus at its source. This could literally be the game changer everyone's been hoping for.
Okay, so to really get why this new approach is such a big deal, we gotta look at where we are right now. And honestly, the best way to describe it is a lifelong stalemate. The treatments we have, they're like a temporary truce in a war. They keep the peace, but they've never been able to deliver a final victory.
And this chart? It shows you that gap in stark terms. The current drugs, they only achieve what you could call a functional cure in a tiny fraction of patients. We're talking less than 8%, sometimes even as low as 1%. That's wild. It means more than 9 out of 10 people are stuck on medication for life.
So what's the core problem here? Well, the antiviral drugs we've been using are actually great at one thing. They stop the virus from replicating, from making more copies of itself. They put the brakes on. But, and this is the huge but, they can't actually get rid of the factory producing the virus. And that means you have to stay on the drugs forever, pretty much, just to keep things under control.
Which, of course, leads to the big question. Why is this virus so incredibly tough? How does it hang on for so long? Well, the answer lies in its hidden fortress. It's got a secret stronghold that has made it basically unbeatable. Until now.
This is the puzzle scientists have been working on for decades, right? With all our incredible medical advances, why is hepatitis B still so stubbornly hard to cure?
Okay, so this diagram shows you the journey of the infection over years. But to really understand why it's so persistent, we have to zoom way in, down to the cellular level. See, this virus is clever. It's sneaky. When it gets into one of your liver cells, it doesn't just hang out. No, it smuggles its genetic blueprint deep inside the most protected part of the cell, the nucleus. That's like the cell's command center.
And once it's inside that nucleus, the viral DNA does something incredible. It forms something called cccDNA. The best way to think of it is like a tiny rogue chromosome that just sets up shop. It's super stable, it's persistent, and it basically hijacks your cell's own machinery to just constantly crank out new virus parts. This cccDNA, that's the fortress. And our current drugs, they can't even get close to it.
So, if you can't storm the fortress, what do? Well, the new plan is brilliant. You intercept its messages. This is a total 180-degree shift in thinking. Instead of trying to fight the virus particles after they're made, the new focus is on silencing the instructions that create them in the first place.
Just look at this comparison here. The old way, it was all about blocking the viral assembly line. The new way, we go straight to the source and we shred the blueprints before the assembly line can even power up. It's just a much smarter, more targeted strategy.
And the science behind this is fascinating. It's called RNA interference, or RNAi for short. Now, this is actually a natural process our own cells use all the time to control which genes are on or off. The absolute genius move here was figuring out how to hijack that system. Scientists have created these tiny synthetic molecules, you'll see them called siRNAs or ASOs, that are basically designed to weaponize this natural process and aim it right at the hepatitis B virus.
All right, so how does this gene silencing actually work? Let's break it down step by step. First, one of these synthetic interceptor molecules makes its way into a liver cell. Step 2, it starts hunting for the virus's messenger RNA. Think of this mRNA as the work order, or the blueprint that gets sent out from that cccDNA fortress. Step 3, the interceptor finds that blueprint and latches onto it, marking it for destruction. And finally, step 4, the cell's own cleanup crew sees the tag, destroys the blueprint, and just like that, production of all the viral parts grinds to a halt.
And this isn't some far-off sci-fi concept. This is happening right now.
This technology is the engine behind a whole new wave of therapies that are already making their way through clinical trials. And we're not just talking about one or two experimental drugs here. There's a whole pipeline of them in the works. You've got major players like Johnson, Alnylam, Arbutus, and Dicerna. They all have really promising candidates in late-stage testing. I mean, this field is moving at lightning speed, which just goes to show you how much potential everyone thinks this approach has.
So to make this a little more real, let's look at a leading example. It's called bepirovirsen, and it's being developed by GSK. This one is an antisense oligonucleotide, an ASO, and its whole job is to find that viral RNA and basically tell the cell to chew it up. The end result? The factory that produces viral proteins gets shut down.
And the potential here is just huge. I mean, listen to GSK themselves. They've said a drug like bepirovirsen could finally address the massive unmet medical needs of all those millions of people who've been stuck waiting for a real definitive treatment.
In fact, the potential is so clear that the FDA in the US has given it Fast Track designation, and that, let me tell you, is a big deal. That's a special status they only give to drugs for really serious conditions where there aren't good options. It's basically the FDA's way of saying, hey, this looks important, let's get this through the process into patients faster.
Okay, so this brings us to a really important final point. We keep throwing this term around, functional cure, but what does that actually mean for a patient? Like in the real world, for their life and their health?
Well, to put it simply, a functional cure means two things. First, that key viral marker, the hepatitis B surface antigen, or HBsAg, is gone from your blood. And second, the viral DNA is undetectable. But here's the absolute best part. This all stays true even after you stop treatment. That's the goal.
So, let's be super clear on what a functional cure is and what it isn't. What it is, it means your own immune system is back in the driver's seat, controlling the virus. It means you can stop taking the medication, and this is huge. It means your risk of getting liver cancer plummets. Now, what it isn't, it's not a sterilizing cure. That means it doesn't completely wipe out every single last trace of the viral DNA from your body.
And really, that's the whole point, the end game. That hidden fortress, the cccDNA, it might still be hiding out in a few liver cells, but with a functional cure, it's been completely neutralized. It can't cause any more harm. The war is, for all intents and purposes, over. The virus is on permanent lockdown, with your own immune system standing guard. For hepatitis B, this is just a monumental leap forward. We're talking about a shift from a lifetime of managing a disease to a finite treatment that ends in a real, lasting victory. And as this whole new era of gene silencing begins, it makes you wonder, right? What other so-called unwinnable battles could this kind of technology help us fight next?